This is the first full indexer test of the cache stack benchmark test. So let me show that. So this is the repository, Chris Troutner, benchmark BCH, and I'm focusing on, here's the cache stack. This test focuses, it's a system level test. SLPDB is not a part of this test. This is the indexer test, which it's a system level test, but it focuses on the indexer's ability to rapidly update its internal database. This test is going to focus on Blockbook as the indexer, and this is a like a baseline test. I'm intending this to have basically the system shouldn't have any problem doing one transaction per second, and that's what we're going to do in this test. And we're going to spend 200 transactions based on 10 UTXOs. So if you click this link here, it'll take you to this page where everything I'm about to say is explained. But it's going to take 10 UTXOs, and it's going to spend each UTXO 20 times. And so in total, it's going to generate 200 transactions. And so because these are child UTXOs, or new UTXOs rather, the indexer will have to rapidly update its UTXO database in order to provide the next UTXO to be spent. And so this test differentiates itself from the full node test, whereas the full node test stresses the full node and its ability to send transactions and process transactions. This test is more of a test of the indexer and its ability to update its internal database, and it should apply across different indexers. So the same test should be able to be applied to different indexers. So, as in the previous tests, this is the standardized system that I'm testing against. There's a REST API. I'm using BCH API for this, but it's basically the same thing as rest.bitcoin.com. It's a DigitalOcean droplet. It's got one processor and 2 gigabytes of RAM. It's talking to a full node that has two processors and 4 gigabytes of RAM, and a Blockbook indexer which has 4 processors and 8 gigabytes of RAM. The Bitcoin full node is running version 0.20.10, and this Blockbook instance is version 0.3.1. And so and so I'm going to be monitoring the performance. I have them set up in DigitalOcean. I'm going to be using these real-time metrics provided by DigitalOcean. So this is a 6-hour window. And so I'm just going to refresh these. And I'll be taking these systems down after the test, but I'm documenting all this so that it can be recreated in the future. So you can see the CPU. This is the REST. The REST application is basically at idle, CPU-wise, very steady state on the memory. There's some spikes in the bandwidth. These are the various tests that I've been running, and then also maintenance for reclaiming funds from the spent test wallets. That's the REST full node, and I'm showing these, and I'm going to show glances so that we can compare the results after the test and see if anything was captured. I don't anticipate that we'll be able to notice a difference in these. But here is the full node, and it's basically running between 10 and 15% at steady state. And you can see its memory profile. This little drop down is where I rebooted the full node, and I upgraded from 20.0 to 20.10. So it uses about 20% of its memory in steady state. Again, the public bandwidth is sort of the only thing that really registers when I run this test so far. And so we can see what that looks like. We can see, this was a test that I ran, some of these spikes. Okay, so that's the full node, and here's Blockbook. This is what we're really going to be trying to stress in this test. 8 gigabytes of memory, 4 processors. CPU hangs out around 2%. This is where I rebooted the container, so this is its steady state. It uses about 55% of its memory. And so it's slowly getting back up there. So it's currently using about 33% of its memory on idle. These spikes in bandwidth, these are from cleaning up a test wallet and running test. But you can see the bandwidth is back down to about 0 because I haven't been running anything for a few minutes. I'm also going to be monitoring during the test. Here's the output of the REST API, and here's glances. This reflects all the data we just looked at in the real-time, in the visual metrics. This is more of like a command line, real-time way to keep an eye on things. This is the output of the full node. We're monitoring the debug log. You can see it's fully synced. This is glances for the full node. Again, it's hovering between 10 and 15%. Here's Blockbook. You can see these are the API requests coming in from the REST API to Blockbook. And Blockbook is running in single-threaded mode, so which makes it a little less performant, but better for testing and standards testing. So this is glances. You can see 2%, about 32% of its memory, or 2.5 gigabytes, and climbing. And yeah, you can see glances is using more processing power than Blockbook is, which is this container D, I believe. And okay, so that's the system. Captured that. Let's do this. Then run indexer test on this wallet. So I should have covered, I'll let this get started. So yeah, it's generating 200 addresses. 200 addresses with a 250 millisecond. It'll try to spend every 250 milliseconds. And I found this to be the right number for this setup of Blockbook. So we can see here it's updating. It's trying to spend every 250 milliseconds, but it's actually achieving a transaction of about 1.5 seconds, or I've seen it lower than this, but right now it's about 1 to 1.5 seconds per transaction. And it's what it's doing is it's generating a new UTXO and then immediately spending it, and then generating a new UTXO and immediately spending that. And so these aren't confirmed UTXOs. These are brand new. These are all in the mempool. And so if we look over at Blockbook, which this is the one it's supposed to be stressing, we can see the output will show up here. But okay, so the numbers are moving. So we're getting live data, and this reflects what I was seeing in the full node tests, is that Blockbook is really not being stressed at all right now, doing about 1 to 1.5 or doing about 1 transaction per second. There isn't any measurable really increase in CPU or memory usage, and it is actively updating its database right now. It's getting the UTXO information from Blockbook in this test, so this is the measure of time it takes for Blockbook to update, to see the UTXO and update its internal database. And again, this is running in single-threaded mode, so this is basically the worst possible configuration you can put Blockbook into. And at the end of the test, it will average the amount of time over these 200 tests. Oh, and a piece of data that I should have captured before doing all these tests, it's important to average the daily transaction volume of the Bitcoin Cash network over the last 7 days. Right now, that is about 52,000 transactions per day. So that the traffic level, I would expect the traffic level on the network over time to affect these results. So that's today. That's the background noise of today. So I'm going to pause the video and just let this complete and get to the 200 mark. So the test is nearly complete, and I just wanted to show some of these other screens. This is the info coming in on the REST API. Here is basically the REST API under test. None of these systems really are showing any level of stress. Here's the full node. Really no change from being at idle. And then here's Blockbook. So while it's taking it time to update its internal database in single-threaded mode, it's not actually stressed in terms of performance. It's just the natural expensiveness of writing to a database. Seems to be a little bit of a slowdown, which is interesting. Okay, so on average, over those 200 transactions, it took 1.4 seconds per transaction. And that's really a measure of the indexer's ability of how quickly it can update its internal database to spend a child UTXO, a brand new UTXO that it's never seen before. Let's check out the graphs. I'll update these. Make sure I'm recording. Yeah, okay. Okay. We said there you can see a very slight uptick in the processor, basically negligible, but it's there. You can also see an uptick in the bandwidth, but not significant. This is the REST API, so no significant change. This is still the REST API is not stressed. Here's the full node. You really can't see anything in here. You can see a slight uptick right here in the bandwidth. That's just the communication between the subcomponents of the system, but memory and CPU usage are basically unaffected. That's what we were seeing in glances as well. And then Blockbook, the memory seems to basically have leveled off, and there doesn't seem to be any appreciable change during the test. CPU usage also unchanged. Again, slight uptick in the bandwidth as it communicates with the other subcomponents, and that's really the only measurable. I mean, you can see there is this uptick, this rapid uptick in the load, so the CPU's working more often, but it's not necessarily working harder. Either way, it's really not appreciable. So this sets the baseline. So 1 transaction per second, or to be precise, 1.4 seconds per transaction is the fastest that Blockbook running in this system in single-threaded mode can update its database to rapidly spend new UTXOs. So this would be equivalent to like a power user that's playing a video game who's rapidly making on-chain transactions. That's basically like, this is the metric that would apply to that use case.